Hello, this is the first of two videos today on absolute value inequalities. What we are going to be solving today is inequalities with absolute values. For instance, we're going to be looking at things like absolute value of x is less than 5 or the absolute value of x is greater than 2. Now, they're obviously going to be more complicated than this, but this is the general idea. So on both of these, I want to look at a number line. I'm now going to draw two number lines, one for each of these problems. Let's start with the absolute value of x is less than 5. Think about what numbers have an absolute value less than 5. For instance, does 0 have an absolute value less than 5? Yeah. Does 1? Yeah. Absolute value of 1 is 1. How about 3? Of course. How about 4.999? Absolute value of 4.999 is 4.999. That's less than 5. How about 5? Absolute value of 5 is 5. It's not less than 5. So my graph would be everything to the left of 5. Now let's look at the other side of our number line. Absolute value of negative 3 is 3. That's less than 5. Absolute value of negative 4, right here, that's less than 5. That's 4. Absolute value of negative 4.9 is 4.9. That's less than 5. But when we get to negative 5 and beyond, the absolute values are not less than 5. Absolute value of negative 5 is 5. That's not less than 5. The absolute value of negative 5.5 is 5.5. That's not less than 5. So our graph would be everything between negative 5 and 5. So our solution would be x greater than 5, negative 5, and less than 5. All right? So we could also write that as x greater than negative 5 and x is less than positive 5. Now let's jump over and look at this problem. What numbers have an absolute value greater than 2? And we could make it greater than or equal to if we wanted to. So, does 1, absolute value of 1 isn't bigger than 2. 1.9, that's not bigger than 2. How about 2? Well, the absolute value of 2 is 2, so that is greater than or equal to 2. So I'll put in my dot there. How about 2.1? Absolute value of 2.1 is greater. 3, absolute value of 3 is greater. So we see that everything to the right is greater. Now let's jump over to the other side. Absolute value of negative 1.9 is positive 1.9. That's not greater. Absolute value of negative 2 is 2. That's equal, so that's good. If I go to negative 2.1, that's positive 2.1. That's bigger. Absolute value of negative 4 is 4. That's bigger. Everything to the left of negative 2. Now, if you remember, when our graph looks like this, it's an OR situation. So x is larger than 2, larger or equal to 2, or x is less than or equal to negative 2. So when we're solving absolute values with inequalities, absolute values with inequalities, the first thing we're going to do, absolute first thing, is isolate the absolute value, just like we did before. Absolute value. Then we're going to write the inequality. We're going to write the inequality exactly as it is without absolute value. And then we're going to write a second inequality. We're going to write a second inequality. And we're going to switch the direction. We're going to switch the direction of our inequality symbol. We're going to change the sign. And we're going to pay attention. I'm going to give you an example here. We're going to pay attention when we do this. Last thing is, if it's the absolute value of something is less than a number, less than 2, it is a AND. If the absolute value of whatever is greater than some number, it's an OR. Okay? We join the two inequalities up here with either an AND or an OR. So for example, absolute value of 1 plus 2x minus 3 equals 7. We isolate the absolute value. So we subtract 1, isolate our absolute value, and then we have 2x minus 3 equals 6. Absolute value is isolated. Now I write, I'm sorry, I'm so sorry, change this not to equals, but I don't know what I said before, change it to a less than. We just need an inequality in there. Okay, now we write our two inequalities. 2x minus 3 is less than 6. And notice that I wrote it exactly like it sits here, but without the absolute value. And then I have 2x minus 3. And I switch the direction, and I switch the sign. Less than, remember, is AND. And then we solve them. So I add 3, 2x is less than 9, divide by 2, x is less than 9/2. We add 3, we get 2x greater than -3, divide by 2, x is greater than -3/2. Now, in today's homework, there are no fractions. So this is a good example with fractions. Now, when we graph it, we have positive 9/2, and we have -3/2. Put -3/2 here. And x is greater than negative 3 halves, less than 9 halves. X is greater than negative 3 halves and less than 9 halves. All right, we're done with the problem. Take note that if you forget, is it and or, the graph should tell you that. You see this kind of graph, it should remind you, oh, this is an and situation. So this would be the graph, and this would be our solution. Both things are necessary. Okay, watch the second video, and then you'll be good to go.